Hi learners, welcome to this session where we are going to discuss section 2 of this CASPA exam. In case you missed in the previous session, I had a discussion of section 1 of the very paper. So learners, the whole of this section we discussed. If you check on my videos, you'll be able to find them there. We are going straight to section 2. That is from question number 17. Invite your friend, share the link. Don't forget to subscribe and hit the bell icon to keep getting updates whenever we post. The diagonals of a rectangle PQRS intersect at 5, 3. Given that the equation of line PQ is 4y minus 9x equals to 13, and that of PS is y minus 4x equals to 5. Part A, find the coordinates of P. So they are telling us that we've got a rectangle. Let's have a sketch of our rectangle, dear learners. This is my rectangle. This is the rectangle. They are saying it's PQRS, and they are saying line PQ is 4y minus 9x equals to 13. Hapa 4y minus 9x equals to 13, and PS is y minus 4x equals to 5. Like that. So we need to get the coordinates of point P. If you look at point P, it is the intersection of line PQ and PS. So to get the intersectory point between the two lines, we simply solve the two equations simultaneously. So the first equation I'm having is 4y minus 9x equals to 13. I'm also having y minus 4x equals to 5. I have to solve these two equations simultaneously. I multiply the first equation by 1, the second equation by 4 to make the y values the same. So that's going to be 4y in the first equation minus 9x equals to 13. In the next equation, I'm going to have also 4y minus 16x equals to 20. So when I do subtraction, 4y and 4y will disappear. Then I'll have negative 9x minus 16, that will be 7x. Sorry, that should be when we do the subtraction, this is going to be, just a moment, let's do the subtraction. This is going to be 7x equals to negative 7. If 7x equals to negative 7, learners, what is the value for x? X will be giving you negative 1. And once we have x as negative 1, to get y, I can replace in the second equation because I know y minus 4 into x, which is negative 1, should give me 5. So y plus 4 equals to 5. Y equals to 5 minus 4, which is 1. So the coordinates for P is the intersectory point. So P is given by x is negative 1, y is 1. Remember, to get the coordinates of the intersectory point between the two lines, solve the two equations simultaneously. That is the secret. You just solve the two equations simultaneously. Let's see how we get equation R. Maybe before that, this is what I need to do. Let me get the diagonals. let me get the diagonals. Those are our diagonals. Sorry, let me use a different ink. Let me use a different ink. Those are our diagonals, learners. Those are our diagonals. The point where they meet here is the point 5, 3. And now they want we get the coordinates of point R. For us to get the coordinates of point R, this is what we are going to do. If the R value, you see, we are going for the X, let's do it down here. I'm going to have the X coordinate. My X coordinate is going to be 2 times 5. I multiply 5 by 2. Then minus -1. That is from P. I'm trying to get the length. From P here. So this gives me that is 11. Let's also work out the solution to get the y coordinate. The y coordinate is 2. I multiply it by this y coordinate intersectory point, that is 3. I'm going again to subtract the y coordinate from P, that is -1. So that is 6 minus 1, that is 5. And that gives me the coordinates of point R. How do you write out the coordinates? We are going to write R into the x value. The x value is 11, 5. 11, 5. That's how simple that question was. Let's see the next one. Let's see the equation of line PQ. The equation of line PQ. How do you get the equation of line PQ? Let's come back here. Sorry, RQ. When we are here, when you look at RQ and SP, they are the same. They are parallel. Now we see RQ is parallel to SP. From the diagram and properties of the rectangle, we expect this one here to be parallel to this. Learners, if they are parallel, what do you know? They have the same gradient. Therefore, I can say, because they are parallel, gradient of line RQ should be equal to the gradient of line SP. And what was the gradient? Look at equation of line SP. Line SP, that is how we had it as y minus 4x equals to 5. Remember, there we had y minus 4x equals to 5. When you rewrite it in form of y equals to mx plus, it will be y equals to 4x plus 5. So 4 is your gradient. So these two equations have a gradient of 4. They have a gradient of 4. Now, because now we know that they have a gradient of 4, remember that to get now the equation, it will become now very easy, learners. We have one of the points in RQ, that is 11, 5. I have to introduce another point, call it x, xy. I have to introduce another point, call it xy, so that it will be now x. Sorry, how do you get gradient? Change in y over change in x. So y minus 5 over x minus 11, this should be equal to the gradient, which is 4. That should be equal to the gradient, learners, which is what? Our gradient, which is 4. our gradient, which is 4. Now when you do cross multiplication, you're going to get y minus 5, y minus 5, y minus 5, y minus 5, 1, y minus 5, y minus 5 should be equal to 4 times x, that is 4x, minus 44. 4x minus 44. That is what you should be knowing. You should be knowing that. So, when we have it like that, learners, the moment we have it like that, so this now is going to be y is equals to 4x. This is that is 4x. Once we have it as 4x, like what happens? Minus 5 crosses the equal sign and becomes plus 5. It will become plus 5. It will become plus 5, learners. Remember, I'm just doing a collection of like terms. I'm just doing collection of like terms. First, I began by taking one of the points in RQ, that is a point R, that is 11.5, formed another one. So change in y, that is y minus 5 over x minus 11 should be equals to 4. So this will be now negative 44 plus 5. That is going to be in your calculator, negative 44 plus 5. You're going to get negative 39. And that will be now the equation of that line. That will be the equation of that line. Let's see the next part. The equation of a perpendicular line drawn to meet PR. The equation of a perpendicular line drawn to meet PR at 5, 3. Drawn to meet PR. We have the line PR. Perpendicular to it is this diagonal maybe. Now, how will you manage to answer that, learners? It's still that very simple. Remember, they are talking about meeting PR. Meeting PR. And when you look at PR, learners, the equation of a line drawn to meet PR at this point. So first of all, let's get the gradient at that point. So how do you get gradient change in y? That is y minus 3. Or maybe before we get into y minus 3, let's first see. They are talking about PR, right? So how do you get, what are the coordinates for P? P we had 1, negative 1, 1. Remember point P, the coordinates for point P are negative 1, 1. Then it's being linked with this 0.53. So first of all, let's get the gradient.